Sugar dissolves in water more readily than in mineral oil because water is a polar solvent capable of forming hydrogen bonds with sugar molecules, while mineral oil is nonpolar and lacks the necessary interactions. When sugar dissolves, its individual molecules become surrounded by solvent molecules, solvation or hydration, which requires energy but is favored by the strong hydrogen bonds that form between water and sugar. This process causes a slight, unnoticeable increase in the total solution volume, as the sugar molecules occupy some of the space between the water molecules. Polarity and hydrogen bonding. Sugar's polarity. Sugar molecules, like sucrose, contain many hydroxyl OH groups, which create polar bonds and a slightly uneven distribution of charge across the molecule. Water's polarity. Water is also a highly polar molecule with a significant charge separation between the oxygen and hydrogen atoms. Hydrogen bonds. The polar nature of water and sugar allows them to form strong hydrogen bonds with each other, a type of intermolecular attraction. Mineral oil's nonpolarity. Mineral oil, on the other hand, consists mainly of carbon and hydrogen atoms linked by nonpolar bonds. This means mineral oil lacks the significant charge differences needed to attract and dissolve sugar. Solubility like dissolves like. The principle of like dissolves like explains this behavior. Polar substances, like sugar, dissolve in polar solvents, like water, while nonpolar substances, like mineral oil, dissolve in nonpolar solvents. Energy balance. The dissolution of sugar in water involves breaking some of the hydrogen bonds within the water and the intermolecular forces within the sugar. However, this energy input is more than offset by the formation of new, strong hydrogen bonds between the dissolved sugar molecules and the surrounding water molecules. Increase in solution volume. Molecular interactions. When sugar dissolves in water, the sugar molecules fit into the spaces between the water molecules. Minimal volume change. While a slight increase in volume does occur as the sugar molecules occupy these interstitial spaces, it is often not noticeable to the eye. The combined volume of the dissolved solute and the solvent is only slightly greater than the volume of the solvent alone.